Hello, my name is Luis Puche, and I would like to introduce SkillCourt 4.0. Now, the traditional way of training soccer players is by having a field, a team, a coach, money, hard work, and dedication. The goal of SkillCourt is to ease down all of these requirements, to get rid of the need for an open field, a team, and a coach, making soccer practice cheaper and more effective for everyone. Now, SkillCourt is a hardware solution as much as it is a software solution. It consists of physical pads. A set of these pads is considered a grid, as you can see right here in the picture. They are walls, and there's also a floor to have sequences that a player can run around in and follow the lit pads. The essence of SkillCourt is that these pads are interacted with. They light up in different colors and react depending on what they have been programmed to do. In the end, it is a revolutionary way of using technology to train players in arguably the most important sport worldwide. I'd like to move further into the development details about SkillCourt with Sebastian Dolce as my teammate. As you can see here on the burn-down chart, we have faced some slowdowns during the development. This were all caused due to either limitations or lack of planning, or just difficulties in the coding process. However, we picked up again later on in the semester. Over on this next slide, these are implemented user stories. Most important of these is the development of a sequence standard, as well as the development of a dynamic UI, which I will go over later. We can follow through on these diagrams which functionality they gave the user, as well as their inner working, including how they were implemented and how they are executed by SkillCourt. In the field of system design, here we can see the architecture pattern used, mostly a model view controller type of system. Due to the nature of this project, the only persistent data that was manipulated was the XML sequence standard, as you can see right here, and I will go over further details later on. In the thought of security, however, the system is beginning to shift from a decentralized, more secure system to a centralized system. The advantage is that a centralized system requires less endpoints to keep secure. The classes used are as follows. Due to the design, some of them vary in function and work with other classes to accomplish a single feature. Now, as I said before, one of the most important use cases is the ability to create custom UI. To explain how it works, Lightweight Java Game Library uses OpenGL. Nifty uses Lightweight Java Game Library and creates a UI from an XML file. Now that we know this, we can test the creation of a valid grid info object, which, as you can see here, runs just as expected, creating our UI. Now, how about something broken? Let's say grid info that has a negative value for either a row or a column. This, of course, cannot be drawn, and it throws an error. This is my introduction to SkillCourt. Again, my name is Luis Puche, and I'd like to thank you for watching.
Thank you, Luis. Hello, ladies and gentlemen. My name is Sebastian Dulce, and I will now introduce the iOS development of the SkillCourt system. As Luis stated earlier, SkillCourt is an interactive athletic training system that uses illuminated target pads. The SkillCourt pads include touch and pressure sensors, which report ball activity. In order to use the system efficiently, it is important to have a user-friendly interface that can show your progress and control the SkillCourt system, so there must be mobile applications. There is already an Android implementation, and my main focus was on an iOS implementation of all necessary features. This involves planning 13 user stories that best cover the features necessary, scheduled as so in the simplified Gantt chart. The user stories I've worked on ranges from registration to settings bundles to creating drill sequences to connecting to Bluetooth, to the SkillCourt Bluetooth. Most of my use cases use persistent data management. So my user story says that as a user, you must be able to save info in order to view and modify later. This involves setting up object models, relationships, and security. That's used throughout most of my use cases, and this use case diagram shows the use cases for the whole iOS implementation. Since most use cases involve persistent data, here's the sequence data for my persistent data storage. Notice that we always have to call the app delegate when we need to get the manage object context. And also notice that I have login view, a controller, and a PF user for storage. That's all part of the MVC design pattern that we employed for mobile development. As you can also see here in the deployment diagram, this is all part of the mobile side of the deployment diagram, where I worked with Bluetooth, the database, and the server for managing data. My persistent data design has a user and a sequence entity, which is a one-to-many relationship. So one user has many entities, has many sequences. Of course, this involves a level of security but iOS 5 helps me out by, it lets me set a key, a private key, in order to encrypt my local data. My class diagram shows the whole iOS implementation of SkillCourt that I've worked on. A class that uses persistent data well is the login view controller. We need the manage object context every time we need to make a change to the model, which we have to get from the app delegate. So by writing a piece of code like this and have a manage object context method, I can use the UI application to get the shared application, get that delegate, and cast it as an app delegate to return to me. By doing this, I can always call self instead of calling all of the delegate methods just to make a change to the model. Having so many classes involves many test cases. So far, I have about 90 test cases and writing more. And these include, for example, verification of a registered user, where I register a user with some credentials and then query the database for the user to see if I get a correct user. For this version of SkillCourt, I implemented the entire iOS application, which includes persistent data, settings bundles, drill creation processes. Any iOS device now can run a SkillCourt product correctly. Thank you for listening. This was an introduction to the SkillCourt 4.0. My name is Sebastian Dulce. Thank you.